Yeah, so this is open to all students, but mainly BME students and material science. And the objective here is really to identify, invent, and implement new medical devices, diagnostics, and other technologies. So I'm sure you've heard it's sort of the culmination of everything you've learned in your undergrad. And I know that sounds daunting, but it's really just an opportunity to apply your knowledge in a real world scenario and a real world device. And it really does help you prepare for the workforce or whatever else you have planned outside of undergrad. So to break down the bioengine process, there are three main parts. The first is identify. So by that, they mean that you're identifying an unmet clinical need that occurs in the real world. Um, and that ties into what you're doing next is you're inventing a solution to solve that need. And then lastly, it's implementation. How can you implement that need to actually distribute your solution to people? So the breakdown of the program kind of separates each of these categories into their respective quarters, fall being identifying your problem, and then once you're going into the actual solution, designing whatever device it is you want to design, and then third is implementation. So it is sort of a lot to ask students to do over the course of just 3 quarters, but that's something you're now aware of, and maybe you can help prepare yourself for that even now, not with before you enter your senior year. And yeah, by implementation, another facet of that is sort of building out, not just having a solution, but having a way to distribute that. So in some sense, a lot of especially if you're going on to the entrepreneurship track, which we'll explain what that is shortly, you're building out not only a product, but also a company surrounding that, which is an important part, right? Because if you have an idea for a device, it sort of is a moot point if you can't distribute that effectively and have it reach the people it needs to reach. And this actually ties into a lot of what we've been doing with the National BMES project. So you guys who are involved with that are very much getting prepared for that for your senior design and getting a head start. So this diagram goes more into the design process. So for identifying a clinical need, same thing, researching the need and what solutions already exist, and then brainstorming how you can improve on those solutions and bring something new to the table. And then just continuing that, you're selecting the best possible solution and then reevaluating that, and then lastly communicating that. And it's a very cyclic process that's always returning on itself in a loop-like manner. So one of the things that you'll have to, that focuses what your efforts are. Oh, sorry, I forgot the music is still going. Okay, I hope it's not distracting. Let me know if it is. One of the things that the course focuses on is this panel that is the business model canvas, and it really summarizes everything that goes into the design process. So on the business side, you have market analysis, value proposition, customer segments, cost structure, and key partners. We won't go into what each of these means, but you can sort of have an idea where there's two elements to senior design, the business side and the engineering side. So that goes again into implementation and the ideation side. On the engineering side, you would have the design process. You learn about the engineering, the FDA pathways, manufacturing, materials and design validation, and protocols testing. So again, you're not alone in this. You have a team that you're working with, and oftentimes you would delegate a person who is specifically focused on, say, materials and design validation. So it's very much a joint effort. And again, tying this back to National BMES, this is actually very reflective of the document we shared with you guys for market analysis, where you identify value propositions. So it's another way that you can prepare for senior design beforehand. Okay, so earlier I mentioned that there is an entrepreneurship track. So if there's sort of two tails of BMEs when it comes to senior design, the industry track and the entrepreneurship track. For the industry track, what happens is companies would have pitched projects to the bioengine program, and at some point in fall, there'll be a symposium where you hear all these pitches, and you would choose which projects you would want to join, and then later on you would get paired with a project, and with that you would have a mentor from that company that proposed the project, and they would help guide you and sort of mentor you along the way of the entire program. So these projects from companies, they're like Edwards, Life Sciences, Medtronic, major companies, and it's really a great way to sort of make connections and network for your outside of undergrad. Besides that, the projects are oftentimes ideas that these companies have but don't have the time or the resources to look into, which is where you come in as students. You get experience and real world application, and they get essentially free labor, but you know, it's still a win-win. Conversely, on the entrepreneurship track, it's not companies, it's not necessarily companies who come up with the idea, but oftentimes students. So a student or I know recently in the past year, some companies have pitched projects for on the entrepreneurship track. Oftentimes this is like a startup company who's sort of still up and coming. But for the most part, entrepreneurship track refers to student ideas. So around fall, at the beginning of fall, you'll have an opportunity to run an idea by Dr. King, who again is one of the instructors, and she'll approve your idea. And if she approves your idea for the project, then you can pursue it for the entrepreneurship track. I remember last year there was the Chalk Zoom hackathon event, which was sort of like a mini hackathon centered around COVID-19. A lot of students and a lot of incoming seniors for BME participated and had an opportunity to work with physicians and other mentors to come up with an idea to a problem surrounding COVID-19. And then after that, you had an opportunity to continue that project if you wish with BioEngine. So that's just sort of one example of an instance where students can come up with an idea early on and then pursue that for senior design. So in the case of people who are involved in National BMES, if you so wish, when it comes time for when you're a senior, you're entering the bioengine program, you could propose your idea that you've been working on for however long through National BMES and pursue that for bioengine, and you'd have a head start, right? So that's one thing to consider. So another difference with the entrepreneurship track is it is more startup based. So compared to the industry track, where the company has already sort of vetted this product, this need, for the entrepreneurship track, you would need to conduct customer discovery yourself and justify that this need is there. So you'd be talking to physicians, other industry experts, and trying to understand, justify that the problem you're trying to solve, whatever it is, exists, and that you can provide a solution. Yeah, another thing with the entrepreneurship track was that it's up to you to seek out your mentors, and Dr. King will help you with this, but it is just something else to consider when you're deciding between the two tracks. So here are some pictures from the BioEngine Symposium, which again is when projects would be pitched and you would sort of gauge which ones you would like to join. In the past, it's been done at the UCI Biot Apply Innovation building, which is really, really nice high-tech building. Hopefully by the time you are a senior, we can go back to that. It looks like a fun event. So besides that structure, the way it breaks down quarter by quarter is as follows. So in fall, there's the symposium, you form teams, you conduct customer discovery if you're entrepreneurship track, and you work on the business model canvas that we showed earlier, FDA regulations. So fall is really sort of laying the foundation and just really understanding the problem and laying all that out for the next quarter, where you would actually start designing your prototype. At the end of fall, you would have a deliverable in the form of a poster presentation. And I know that they recommend you apply for either Europe or the Student Startup Fund in order to gain extra funding for your project. In winter, so you start designing your ground zero prototype. Ground zero means it doesn't have to be fully functional, but simply proof of concept at the minimum. And in spring, you would actually start testing and validating that prototype in preparation for the final presentation, whether that be Europe should you be accepted or just the class presentation. So this is sort of the guidelines, and this is subject to change according to how far you get. But generally speaking, this is how the cookie crumbles. But with that said, everything outlined here isn't exactly what happens in lecture. This is sort of your goals as a team outside of lecture. During lecture, you would have guest speakers, whether they be physicians, alumni, or people talking about FDA regulations or other entrepreneurs, to give you a sense of their experiences. And I know another thing they do is have a lecture on how to make a website, which is one of the things you'll have to do, build a website for your project. Okay, that concludes the slides provided from Dr. King. Are there any questions, general questions about the logistics of senior design? Feel free to type in the chat or unmute. I'll verbalize the questions, but also the seniors feel free to chime in. How do you get an idea approved by Dr. King to take the entrepreneurial pathway? From my understanding, she sends out a mass email at the beginning of fall, and then you would have to submit a description of the project, and then some other details by a certain deadline, and then she would approve it from there. Megan, maybe do you remember the other stuff? Or Phoebe?
For entrepreneurial, so say like for example, my team, we are on the entrepreneurial track, and then she does send out the mass email for if you have your own idea for senior design, she sends it in the summer or like prior to that. So really early on, so during Bioengine when that's happening, then you can email her your idea along with like a base prompt on what your idea is. And then if you have any people on your team, and she'll either approve it, and then from there you're on the list for potential projects that people can join, and then you can choose if you want to be industry or entrepreneurial. So it's kind of just straightforward. You can be like, I want to do this track. It's up to you.
Awesome, thank you. Next question was, how big are the project teams usually? Any of the panelists, feel free to chime in.
It's anywhere from 5 to 6 people on your team. Even though I think actually this year in our cohort, we have actually a team of 3, I think. But yeah, it depends on how many people. But usually, yeah, she wants 5 to 6 people on per team.
Thank you, Nancy. Next question, are industry projects run on a first come, first served basis?
I can answer to that, most definitely. You should definitely, if you find a project you're really interested in, contact those industry representatives and try to get a meeting going so that they could recommend you for the project and secure it.
A comment on that, maybe Rini can talk about her experience briefly. I think one recommendation she had was to sort of find people who are come across people by whatever means you want that are looking at the same project, and then as a group contact their representative to give you better odds. Okay.
Can I chime in a little bit?
Yeah.
Or is reading it? Okay. So yeah, for this, still like I would say that usually the 6 people team, if they like right away act and like contact the industry person, they're more likely to get matched with the project, even though like specifically the instructors say it's not a first come first serve basis, but I guess the faster you get it in and like your whole team has to come into a like agreement that you want that, and like because you guys have to list your top 10 choices, and so all of your team has to like for sure like have the same ones. And then again, I think I for sure see that's more preference for the teams that have 6 people on their team.
Thank you. Okay, we'll go to the next question. How are teams formed? If anyone wants to add to that.
I can answer that. So it depends. So for my team, I started with another senior design that I worked during junior year in the mechanical engineering department. So I was forming the team for stroke rehab that was in the biorobotics lab. So that's how my team started. Some team I saw started from 60C. So they had an idea they work on during BME 60C, and they really like it. They wanted to take to the next level, to the entrepreneurship where they can sell their product. Some team did that. And there are other ways too. So the first few weeks, if I'm not mistaken, so the first few weeks you have basically teams who are already formed, can pitch their ideas on that one day, and then you can, if you have not had a team by then yet, then you can listen to the pitches from the team that already formed. If you like their project, what they're working on, you can reach out to them to join. There's also companies also pitching their ideas or their projects as well, in which you can reach out to them. So yeah, so there are many ways.
I just want to add on to that too. Like kind of as like a last resource, if like you don't have any teammates or a team that you're on or project, there is like, at least for us, for virtually, we had like a Zoom dating event. Actually, it was over Discord. It was like a speed dating event where like all of the people who had like incomplete teams, they would be on a voice channel, like their own voice channel. And then people who are still looking for teams can join all the different voice channels for projects that they're interested in. And yeah, you would just talk with them, and they would have to pick you to join their team. And then like worst case scenario, the TAs will just put you on a team.
And to on with that, typically, I think if I recall from, I think the TAs or Dr. King, since everything was virtual, we had the Discord server, and then if you guys get to go back, it's usually like in a building, like in person, you're talking with everyone. Like that's how it would go.
Awesome. Thank you, everyone. Next question was, how likely was it that the team would go on to actually start a startup? I can speak a little bit about this. I was part of, as an undergrad last year, and some other programmers actually also, we were assisting a senior design team in a project at the end of the year. They're going to make a wearable company. I know their project didn't reach the point where they could actually start a company. And in those cases, I believe that the project is often recycled into the pool for anyone who's going to keep it going for the following year. I think there have been a fair amount of projects that have become successful companies. One that comes to mind is called Stenson. I'll type in the chat. I don't think it's that common. Anyone else wants to?
Yeah, I can say Sensen was during my year. So yeah, I think they're definitely still going, but they were the only one of my year. So that's what I could say about that.
But don't let that discourage you, especially if you're
Yeah, I think it was because they just really wanted to make it a startup. I'm not sure that the other ones were that adamant about it.
Right.
So that's why it was just because they didn't really see themselves doing that.
Yeah. Okay. Next question from for industry, are the people on the team based on those who picked the same one? Okay. Do you have to pick your team members?
Wait, could you repeat your question?
Do you get to pick your team members?
Do you get to pick your team members? Yeah, you do.
Can they get approval before senior year?
Yeah, some people King had like some sort of deadline like over the summer if you wanted to get approval before the quarter started. So it's possible to get approval for your project before school starts.
Mm-hmm.
But I don't know how earlier on before that you can get approval for a project.
That makes sense. I think if you're interested, you should reach out to Dr. King and then she can help you. Are the companies always the same? I think it changes year to year. Yeah.
Hey, Francis, I think your mic's cutting out a little.
Apologies. I'll just talk louder. Is that better? Okay, cool. I'll take one last question before we move on to the individual list, and then we'll keep it going afterwards. When do the company lists come up? And during the symposium, are there common companies that usually volunteer?
Phoebe, you were gonna say something?
I was like,
Go ahead, Phoebe.
Sorry. I think for companies, they release a list about like I think 2 or 3 weeks into the quarter. I'd say.
Yeah,
At
that's
least
what I was gonna say too.
Yeah, at least before you do the team speed dating, I'd say. And then common companies, I'm not too sure unless Rini or Natalie knows.
I always see Edwards.
I don't know if Medtronics are regular, but they've been up there too. But I don't know what companies were before me, and Nat doesn't know what companies are after her. So
yeah, I was also during my year. There was one. She was a doctor who had a clinic, like an independent practice. So that was it. Wasn't really your typical biomedical company.
yeah, sometimes the industry sponsors and companies aren't actually companies. They could be clinicians, UCI doctors. Sometimes I don't know where it falls, but there's also professors with their own ideas. Do I think that falls under industry? I'm not sure.
Yeah, the physician. My team worked with the UCI physician. That was industry.
Okay, thank you everyone. Great questions. We'll now move on to individual presentations. So each of the panelists have prepared a brief overview of the project. And if you have any questions specific to the project, feel free to ask afterwards. After all the panelists, again, we'll be going over general Q&A. So first off is Rini, who, to give a little introduction, is actually BMES alumni. He graduated last year and was our secretary. and currently is a grad student at Duke University. 3, you have the floor.
Oh, okay. Hi, Ruth. Yeah, so I could give a little brief intro. I graduated in 2020, BME. I didn't have any minors. I did do a concentration in micro and nanotech just because that was something that I had a little more background on from research. So I kind of followed through with that. Right now I'm doing my Master of Engineering at Duke, and it's a 1.5 industry-based grad program, master's program. So I'll be finishing that up this December. Yeah, so to get started, the Billy Beanie by the Neomates, that was my senior design. The Neomates are these 5 incredible women. We were just like, honestly, it was one of the best experiences I've ever had on a team. It was also exceptional just because it was 5 women and we were all working together, and it was kind of like a boss lady type of team. So here I just brought down a couple of my roles, but I could get started by explaining what the project was. So the Bilibini is a product that's supposed to prevent eye damage while neonates are under phototherapy. So when a baby is born with jaundice, they need to go under blue light treatment. And so when they're under that blue light treatment, you need something to cover their eyes. And the current masks that they use, they don't cover the eyes all the time. When the baby moves around, their eyes can get exposed and the mask shifts. So our design was brought to us by our industry sponsor to create a different type of design that just makes it more effective and the babies won't get exposed as much. So as you can see by our design, we came up with the beanie design. And our industry sponsor was the Innovation Lab, and that is a kind of incubator for a lot of different ideas. And it's connected to 6 different hospital chains throughout the country. And so whenever some nurse or doctor has an idea, they'll submit that idea, and then this innovation lab will go through, look up any patents, see if they can actually start solving it, and then they'll work with the nurse or the doctor to try to make their idea come alive. So we were working with a nurse from Children's Hospital Orange County, and she was working in the NICU, and she saw this need of all these babies' eyes getting potentially damaged. They don't have much research on it. So she came up with this basic beanie idea, and she told us, like, have a crack at it, 5 engineers, see what you can do. So a couple of my roles are up here on the slide. My main role was as the business marketing advisor. So a lot of this involved asking nurses and sending them surveys of what the clinical need is, finding out what they like about the products out there right now and what they want, and trying to get a feel for what this product would be solving later on. And then also did a ton of research on competitors in the market. And I think that's something you don't realize until you come in senior year, where you have all these ideas floating around in your mind, but if someone already has a patent on it, you can't really go forward with it. So doing a lot of research on competitors and seeing what's out there and seeing how you can be unique and having your own unique value. That's a big one. And then team branding, I think it worked really well with our team because we were 5 women and we were dealing with babies. So the Neomates name, like once we came up with that, we kind of structured our brand, and it was one of the best, I think Kine or King, someone told us that like we were one of the best branded teams, just because all of our slides look the same every semester. We had the same formatting. We like sometimes dressed in the same shades, as you can see on that picture. We really took into heart the effect that team branding has, and how you present yourself can help you sell your product. And then I was also on materials research. And so this was because it was a beanie, we needed to research
a lot of different materials that can be soft on babies' heads, but still work and not let light through. So a lot of different factors and a lot of anatomy research as well. And then before COVID hit, I was on this testing sub team. So we created a lot of testing protocols and wrote everything up and started doing a little bit of testing, and then COVID hit. So we went home, and then we actually used our sewing machines that we bought for our original Billy Beanie and started just sewing masks and trying to help out at the time because it was the beginning of COVID. But yeah, that's kind of a run through of that.
Awesome. Thank you so much. Okay. Really quick, any questions for Rini before we move on? Okay. Next up, we have two current, Meghna and Yuki, and I'll let them share their screen.
Hello. Can you see my screen all right? Okay.
Yes.
So, okay. Hi, I'm Meghna, and I'm part of Vina Vitals, which this is the industry track, and we're creating, Yuki and I, along with other team members who couldn't make it, we're creating a self-calibrated continuous blood pressure monitor system. And our mentors are Dr. Joshua Kim and Mr. Ray Liu, who are also part of Vina Vitals. So a little bit of background about blood pressure is that it's related to some of the leading causes of death in America. Some of these include heart disease, stroke, and kidney disease, as listed here. And between 2011 to 2014, almost half of the American population had high blood pressure. So there's a clear clinical need to be able to monitor it effectively. And so for one way to monitor blood pressure is with a blood pressure cuff, which I'm sure most of you have seen before at your doctor's office. And it's a non-invasive way of measuring blood pressure, and it is accurate, but the problem with it is that the readings are recorded intermittently. So if you look at the graph on the right, you could see a continuous blood pressure waveform in red. And then if you notice, the diastolic blood pressure is recorded after some time has passed from when the systolic blood pressure was recorded. And so this is an issue because blood pressure can vary a lot in between these readings, and a lot can go unnoticed. And so the arterial line cannulation is another way of measuring blood pressure, and it is able to measure blood pressure continuously. However, it is invasive, so that can lead to blood vessel damage or other increased risks of infection. And next, I'm going to pass it off to Yuki, and she'll talk about our approach for resolving these issues.
Hi everyone, I'm Yuki. So currently the Vina Vitals blood pressure sensor uses a wrinkled surface technology that measures the blood pressure. And we're working on the addition of a single lead ECG wrist device to allow for pulse transit time calculation in real time. And this measure correlates with pulse pressure, so it's able to be used to self-calibrate the blood pressure signal from the units of picofarads to the standard units of millimeters of mercury. And this design is intended to provide a more accessible way for patients to monitor risk factors from diseases like heart disease. And additionally, we're also working on a foot form factor for the blood pressure sensor. And this foot form factor provides an alternative signal acquisition location. And in this design, we used a movable platform as a pressure modulation feature where the volume of a gel packet will be compressed and to adjust for the pressure applied to the sensor. And currently, the updates on our project is that we've finished the initial prototypes for this foot form factor and the single lead ECG monitor. And next quarter, we'll be working on more of the testing phases for these two products and finalizing all the designs. And now we're going to talk a little bit more about our experience with senior design. So Magna can start off first.
Yeah, so for me, it kind of feels like a more advanced version of BME 60C. I feel like, at least in 60C, I didn't really get to contribute as much as I wanted to. So I feel like senior design is another opportunity to be able to work on prototyping and like gain a better foundation for like all the engineering skills you need to work in industry.
For me, I think senior design really opened my eyes to the amount of like the long process of developing a product and putting it into market. Like in class, we have so many assignments on just dealing with different regulations that apply to our products and the testing procedures and things like that, that I think we haven't learned in any of our previous classes. So I feel like that was really eye-opening and interesting for me.
Yeah,
everyone.
Oh, sorry.
Sorry, Megan.
I was just going to ask if the audience had questions. What were you going to add?
Same thing.
Okay.
Okay, thank you guys. I think it's pretty universal that that logo is amazing.
Thank you.
Okay, next up we have Nancy, who is also a current senior, and she'll be talking about her project, Stentacular.
Okay, let's see. Quickly. Okay, so hi guys, can you all see my screen, hear me all right?
Yes.
Okay, thank you. So yes, I'm Nancy, fourth year BME, and specifically, yes, I'm vice president for BMES, and my team is, we're called Team Stentacular, and we're made up of 5 biomedical engineers, including myself. And my project specifically, we're on industry track, and we're in collaboration with Medtronic. We have 3 engineering mentors, and our project specifically is semi-automated CAD modeling of braided stents. So stents is basically like a medical device, right? That's implemented into blood vessels, and specifically for our project, it's blood vessels in the brain to help alleviate brain aneurysms from bursting. As you can see the image there, an aneurysm is basically when the side wall of a blood vessel starts to weaken and it sort of starts to like plunge out, and then as more blood continues to go into that wall structure, it continues to grow until it ends up rupturing. And this is a problem because this could lead to hemorrhagic strokes and even death if it's not caught on time. So our project goal, we're basically sort of creating more of a 3D, like, well, it's like a software where we use Python to code a whole script where that's then interfaced with a GUI, which is a graphical user interface. That is where they'll make it easier for like an engineer to just change certain parameters that are really important for stents, such as like number of wires, the diameter of the different wires as well. And so literally just by being able to change those numbers in that GUI, the script will run, do the mathematical equations, and it'll basically pop up the 3D model in SolidWorks. That's the goal. So for our timeline, this was initially when we started. We were starting with a stage 0, which was like background research, getting adapted to what it was, the whole project, and then going into stage 1, which was then like using our Python script to then integrate with SolidWorks, and then our GUI as well. And then stage 2 was more of like integration with Abacus, which is another software to evaluate the criteria for like, okay, making sure once the model was printed out, make sure it was abiding all standards. But now we actually run onto the issue where it took us more time to get adapted to using Python, since none of my team members usually had like a strong foundation using the software. So we decided to take more time to learning it, and actually one of our mentors had way more of a background in this like software-based technology. So he was like giving us, additionally to our 1 hour meetings, we would have 2 hour meetings where he would like teach us everything from like how to use Visual Studio Code, which is another software that utilizes Python, and GitHub, which is a really good platform to keep track of our changes as we change different parts of our code. So really helpful. But now that we're sort of getting adjusted to that, we are scrapping our stage 2, since we're probably not going to have time for that right now. We're all working on our individual parts of our code and utilizing more GitHub and like making sure we're keeping track of our changes. And then we're going to move on slowly to develop our GUI. And then we're approximating, hopefully within the last 2 months of spring quarter, we're going to be more focusing on validation and just making sure that our models that are being printed out right from the code are accurate and there's no like wires intersecting each other, and obviously just abiding all those protocols. Let's see, why don't you move? There we go. Okay, yeah, so picture, this is my team. For experience, it's definitely been a large learning curve. Obviously, not knowing that much anything about Python, and being that this project is really heavy on coding, and it took us quite a while to get used to like all the software that we've been introduced to. But I really think that our team is really made up with like a lot of different people that have different strengths and weaknesses. So we each complement each other, I feel, and that's how we have been able to keep pushing through. And for sure, winter quarter, it really hits different. It's the quarter that you really start building your prototype, like really doing a lot of iterations and really working hard into it. So definitely we see the stress is there for sure. And right now that we're doing final presentations, it's definitely been tough, but I guess I really enjoyed it though. Like actually sort of like backtracking, like my project, we got matched to the project like week 5, week 6, just because we initially, after we had jotted down our top 10 choices, the professors were like, oh, we'll try to give you your top 5 choices, and we ended up matching to our 6th choice, which was like more entrepreneurial track. And how the project was pitched to us, it was like a last year's senior design project, and we didn't see sort of like a future in it, and we didn't think that we were going to be doing well. So we're like, okay, let's see what projects are available. We saw Medtronic was available, and even though it would take us, like, again, it was a large learning curve, we thought it was more beneficial. We obtained more of a technical skill. So definitely we don't regret switching over. But yeah, thank you. And then, yeah, I won't take questions right now because we're a little bit behind of time, but feel free to ask after at the end.
So thank you for sharing. Yeah, we'll hold off questions till the end, and we can jump right into our next speakers, Hui and Phoebe, who are also current seniors, and they could talk about their project Respatial.
So I know we almost run out of time. Keep it quick, and I have some demo. I hope you guys can get a little bit more engaged for the last few minutes. All right. Don't worry, it looks long, but it's not going to be long. Okay, hi everyone. My name is Hui. I am the team leader, and one of the team so our team's Respatial, and one of my team member is Phoebe, who is on the board.
Hello.
And we are the entrepreneur track. So we're building an interactive gaming device for left spatial neglect in stroke rehab. And our mentor is Dr. King. So our objective is to build the interactive gaming device used in clinic to assist moderate stroke patients to train their left spatial neglect symptom, which is a symptom in stroke for patients who come after their stroke. And to for our project, we spent the whole fall quarter to understand the problem. So I think Francis mentioned earlier about for the entrepreneur track, we have to really understand our problem through interviewing. So we did that through pretty much the whole fall quarter. So we went to the trying to remember the physical rehabilitative center at UCI. We interview with therapists, patients themselves too. We asked them about games, about pretty much a lot of things like how their experience at the therapy session is. And from that kind of interview, we were able to understand more about left spatial neglect and stroke rehab, and how the process goes and what is important during a session. So to go a bit more into what exactly left spatial neglect is basically a psychological disorder that comes after a hemispheric stroke. So when a person has this kind of symptoms, what happens to them is, you can see from the picture here, they just don't see their whole left side at all. They even though they have some kind of strength on their left arm, but they just don't use it because they're not aware of that side existing. And this occurs in about 82% of post-stroke patients. It generally affect more on the left side than the right side. There are right spatial neglect, but for right spatial neglect is not as bad as the left spatial neglect, meaning that for right spatial neglect, they can still recognize a little bit on their right side, but for the left side, they just can't recognize the left side at all. So yeah, this is our device, and it consists of a controller that you can see from here. The controller is being pushed against these springs, and all of this, the springs, why it's there, we base it off from the current therapeutic techniques that we interview with the therapists on what they do to train patients for to help with their left spatial neglect. So we base it off that so we build the device from there. And what this device does is, as the patient would just push onto this controller, the sensor would recognize the distance away from the controller, and we have a Raspberry Pi here that would take in the data from there and then translate into the movement of the game. So you can see here, some of you may recognize that's like, wait, it's Flappy Bird. Well, it is Flappy Bird, first of all. So we base it off of the idea of Flappy Bird because we like the movement up and down, and we like how challenging it can get. The cool thing about this game, you see, is that Flappy Bird, usually you see it moves from the left to right. We make it moving from the right to left. So the idea is to make the patients basically always try to look to the left. So you can see here, that's why the game's a little bit backward from where it used to be. And this is our current progress. As you can see over here on my so I got a little bit of a short clip there. It's pretty hard to control in my hand, but once we integrate with the whole device, I think we can get a much better game session. But yeah, that's pretty much for my presentation. And Phoebe, if you want to chime in on anything.
No, I think you just about covered it. So.
Thank you guys. Really cool project. Okay, our last panelist, last but not least, is Natalie. To give a short intro, is our president from 2 years back and is currently a grad student at USC.
All right, about to share my screen here. Okay. Okay, it's spazzing out. Can everyone see this okay?
Yeah, that's good.
Okay, okay. All right. So thank you, Francis, for the introduction. Yeah, as Francis was saying, I am a part-time graduate student at USC, and I actually have a full-time job now at a startup company in Anaheim called Vascular Medcure. But I guess back to senior design. So for my senior design, I was on the iLuminate team, and my team and I developed a device that would create 3D ultrasound images of the eye for visualing abnormalities within the eye. So just to give a quick background, the current technology is for a physician to place an ultrasound probe in contact with the patient's eye. And what they end up getting is cross-sectional images within the eye. And the limitation of this is that these cross-sectional images are two-dimensional and provide a very limited view within the eye. So what my team did was we developed a casing for the probe, and this casing would rotate the ultrasound probe around the patient's eye, and it would collect spatiotemporal data that would then get sent to a software, and the software would create this 3D ultrasound image of the patient's eye with the rectus muscles and the optic nerve labeled so that the physician has a clear view of any abnormalities with respect to these anatomical locations. So that was kind of a main technology background. For my personal role in the project, I was a lot on the design side. So I led the team on the prototyping side. I wasn't too much into the business side, but some of my teammates, I know that they really learned a lot from that experience of kind of going into competitors, what's out there, where the company was a company where it could go. And I guess the way we got the project was this was our second choice actually, and my team and I think we really liked how this project really combined a lot of things together, and especially we had some people on our team who are really interested in the machine learning side of things. So this area over here where we're having these 3D images and we're wanting to label anatomical locations using machine learning was very appealing to them. And we worked with a physician from the UCI, the Galvin Erbert Eye Institute, Dr. Andrew Brown. I highly recommend if you're interested in eye research, you contact him. He's doing some really cool stuff. Last thing I heard of this project, it got handed off to a group of computer science majors after us. So I think they just, they really wanted to get that machine learning going, as I was saying, because my team made a lot of progress on the hardware. So now they're wanting to get the software up and going. So if you're interested in that kind of thing, highly recommend reaching out to either Dr. William Tang or Dr. Andrew Brown. They're amazing mentors, and I'm happy to take any questions after.
Hey, thank you so much.
Sharing.
Yeah, and we'll open the floor for questions now. Apologies for running a bit late. I have a couple questions, I guess, just in any of the panelists can chime in. Advice-wise, do you have any advice for how to prepare for senior design before your senior year? And what experiences you think helped you be successful?
I think for me, I don't know how much to say about preparing before your senior year really starts, but keep your mind open to different ideas. So I think Francis touched a little about how my team formed, but basically I did not stay in a team that I always worked with. My team was actually formed by, basically I watched everyone at the pitch night and saw who talked to the one person's project that I wanted to go into. And so I talked to the lady, the sponsor of the project. And then after I talked to her, I watched who else walked up to her, because that means they're interested. And then I just like wrote all those names down and then messaged them that night or like the next day or something. And it's like, okay, I saw you were interested. I'm interested in it too. And I think that's a big thing. Don't go in wanting, like staying steadfast on I want to be with my team, because there is a chance that you're all going to have different interests. Like if someone likes machine learning and someone doesn't, like you want to make sure that you're all interested in the project itself, because that's what you're working with. So I guess my advice is just like take a risk, meet new people, even it could be helpful.
Thank you. Anyone else want to chime in before we end it?
Well, I guess I could add, for my team, we knew each other before, but we knew that we worked well together before. So if I were to give anyone advice, it would be, you know, just keep in mind how well you work with the person. Of course, you know, going with friends is all fun, but like Rini was saying, they might have different interests, and you know, it just might be that you work better with other people. So just keep an open mind going into it. Don't like feel too pressured about, you know, I want to be with this team or I want to be with this specific project, because you can always get yourself to kind of go outside of your comfort zone and learn new things.
I think another big thing is a lot of senior design and going out into industry is paperwork. So don't think the paperwork is stupid as much as you want to. There's so much paperwork involved, especially once you go into industry. I think Nat could also talk about that a little more. But there's just so much there. So make sure you're organized. Make sure your team lead is the most organized person you can think of, because that really helps. And just make sure that everything is very, like your project management and your team management is really structured and going well, because you could have great designs, great CAD, but if your team's not doing the best in the project management sense, like everything's going to fall apart regardless of how great your ideas are.
Yeah, definitely take lots of notes. Like everything that you do, write it down. Try to have even include reasons why you did things, so that when you're looking back or when you're giving the team on or the project onto the next team, you'll know exactly what you were thinking. Some people I know have kind of done their master's thesis based on their senior design project. So, you know, it's always a possibility.
Okay, thank you both so much. It's really great advice. There's no other questions. I think we can wrap it up there. Thank you everyone so much for coming, and a special thanks to all of our